Good morning to one and all present over here. Today, I, Ruchi Desai, with my group members Kushal, Divyaraj, Sai Krishna, Prathamesh, Bhautik, Yashvi, and Hetvi, we are here to give you a short explanation about epidemiologic approach, their descriptive and analytical approach, potential errors in epidemiological data. Descriptive epidemiology. The image above illustrates the 10 essential functions of the public health. The epidemiology it plays a particularly important role for three of the functions, especially monitoring, investigating, and evaluating. The 10 essential public health services describe the public health activities that all communities should undertake. The public health system should first monitor health status to identify and solve community health problems. Second, diagnose and investigate health problem and health hazards in the community. Third, inform, educate, and empower people about health issues. Fourth, demobilize community partnerships and action to identify and solve health problems. Fifth is to develop policies and plans that support individual and community health efforts. Next, enforce laws and regulation that protect health and ensure safety. Link people to needed personal health services and assure the provision of health care when otherwise unavailable. Next is to assure competent public and personal healthcare workforce. Ninth is to evaluate effectiveness, accessibility, and quality of personal and population based health services. And last is to research for new insight and innovative solutions to health problems. Specific task of descriptive epidemiology is the specific tasks of descriptive epidemiology are the following: monitoring and reporting on the health status and health related behavior in population, identifying emerging health problems, alerting us to potential threat from bioterrorism, establishing public health priorities for a population, evaluating the effectiveness of intervention programs, and last, exploring the potential association between risk factor and health outcomes in order to generate hypotheses about the determinants of the disease. Next, I would like to call upon Sky to continue forward.
Good day everyone, myself Sky. Now I am going to tell everything formulation characteristics of person, place and time. Descriptive epidemiology serves the patterns by examining characteristics of place, person and time. These characteristics are carefully considered when a disease outbreaks occur because they provide important clues regarding the source of the outbreak. Person. Information about the case is typically recorded in a listing, a bit on which information for each case is summarized with a separate column for each variable. Demographic information is always relevant, example as age, sex, and address, because they are the beginning of an investigation. A small number of cases will be interviewed to look for some common links. They are referred to as hypothesis generating interviews. Depending on the means by which the disease is generally transmitted, the investigator might also want to know about other personal characteristics, such as travel, occupation, leisure activities, use of medications, tobacco, and drugs. Next slide, please.
Just a minute.
Yeah, it was done. Please. Assessment of an outbreak by police providers the information on the geographic extent of the problem and analysis show clusters or patterns that provides clues to the identity and origin of the problem. A simple and useful technique for looking at geographic patterns is to plot on a spot map of the area when affected people use road or may have been exposed. A smart spot map of cases may show clusters of patterns that reflects water supply, wind currents, or proximity to a restaurant or investigating the source of an outbreak of infectious disease. Investigators record the date of the onset of disease for each jurisdiction and then plot the onset of new cases over time to create what is referred to as an epidemic curve. Epidemic curve for an outbreak of hepatitis A is shown in illustration below. Beginning in late April, the number of new cases rises to a peak of 12 new cases reported on May 12th, and the number of new cases gradually dropped back to zero by May 20th. Knowing that the incubation period for hepatitis A average was about 28 to 30 days. Investigators concluded this was a point source epidemic because a cluster of new cases all occurred within the span of a single incubation period. The explanation on the next page, as this conjugation with other information provided important clues that help shape their hypothesis about the source of the outbreak. This graph determines the time duration for the hepatitis A and the other factors that can produce changes in disease frequency over years or decades. If the frequency of a disease or mortality from a disease change over time, there are several factors which could be responsible, changes in incidence due to environmental or lifestyle changes, improvement in diagnosis may increase the cases reported even though the incidence may not be changing. Changes in record keeping accuracy can create what appears to be change in disease rates. Improved treatment may decrease mortality rates. Change in the age distribution of the population can produce change in the overall rate of disease, even though age-specific rates are not changing. Now, myself, my fellow friends, Ratanesh will continue.
Analytical epidemiology. Second, second major type of epidemiological study. Subject of interest is the individual of small groups of individuals in contrast to respective studies where researcher deals with larger population. Test the hypothesis. Statistical association between a disease and suspected factor. Strength of association. Inference is to population. The subject is interest is individual within the population. Inference is to population from which individuals are selected. Next slide. Features of analytical epidemiology. Both expose and outcome have occurred before the onset of the study. Study proceeds backwards from effect to cause. Use a control or comparison group to support or refute an inference. Next, please. Steps in analytical epidemiology. Selection of case and controls,
Prathamesh, this
matching,
slide will be
measurement of
spoken by
explore,
Divyaraj Singh.
last, analysis, and interpret. Next, Divyaraj Singh. Divyaraj, Diviraj. Next.
Next, critical epidemiology. First, selection of cases and controls. Second, matching a measurement of exposure. Fourth, analysis and interpretation. Next slide. Selection of cases and controls. Yeah. Selection of Next, selection of cases and controls. Selection of cases. Define the cases, diagnostics criteria, eligibility criteria. Now, source of cases, hospitals and general population. Next, selection of controls. Studies. Control must be free from the disease under study. Control must be similar to the cases except for the absence of the disease under study. Next, sources of controls. Hospitals, relatives, neighborhood controls, and general population. Next, matching. Definition the definition the process by which we select control in such a way that they are similar to cases with regard to certain parent selected variables, which are known to influence the outcome of disease and which, if not adequately matching for comparability, could destroy or confound the result. Next, confounding factor. One which is associated both with exposure and disease and is mm, distributed uniquely in study and control groups. Although associated with exposure under investigation, it is a risk factor for the disease. Example, alcohol, esophageal cancer, confounding factor, smoking. Do not match the suspected ethological factor. Method of matching, group matching and matching by pairs.
Prathamas.
Measurement of explore. Explore can be measured in interviews, questionnaires by studying past records, example. Bias should be avoided while measuring the explore by blinding the investigator. Analyze. Involves two steps. Explore rates among case and controls to suspect factor. Elimination of disease risk associated with explore. Odds ratio, cross product ratio. It's a key parameter in the analysis of case control slide, a measure of the strength of the association between risk factor and outcomes.
Potential errors in epidemiological data. In scientific research, measurement error is a difference between an observed value and the true value of something. It's also called observation error or experimental error. There are two main types of measurmental errors. Random error, which are different between the observed and true values of something. Example, a researcher misleading inexperienced records as incorrect measurement. And second one is systematic error, is a consistent or proportional difference between the observed and true values of something. Example, a miscalibrated scale consistently register weights as higher than they actually are.
Random error introduce variability between different measurement of the same things, while systematic errors moves your measurement away from the true value in the specific direction. When you only have random error, if you measurement the same thing multiple times, your measurement will tend to cluster vary around the true value. Some values will be higher than the true value. True score will while other will be lower. When you average out these measurements, you will get very close to the random error. Affects your measurement in unpredictable ways. Your measurement are equally likely to be higher or lower than the true values. In the graph below, the black line represents a perfect match between the true score and observed score of the scale. In an ideal world, all of your data would fall on exactly that line. The green dot represents the actual observed score for each measurement with random error added. Next, core of random errors. Some common source of random errors include variations in real world or experimental context, impresses and reliable measurement instruments, invaluable individual differences between participants or units, poorly controlled experimental procedure, reducing random error. Random error is almost always present in research, even in highly controlled setting. While you can't eradicate in completely, you can reduce random error is using the following method. Next, continue to Fusal.
Take repeated measurement. A simple way to increase precision is by taking repeated measurement and using the average. For example, you might measure the wrist circumference of participant 3 times and get slightly different length each time. Taking the mean of 3 measurements instead of using just one bring you much closer to the true value. Increase your sample size. Large samples have less random error than small samples. That becomes the error in different direction cancel each other out more effectively. When you have more data points, collecting data from a large sample increase precious and statistical power. Next slide. Systematic error. Systematic error means that your measurement of same thing will vary in predictable ways. Every measurement will differ from true measurement in the same direction and even by same amount in same cases. Systematic error is also referred to as a bias because your data is skewed in a standardized way that hide the true value. This may lead to inaccurate conclusion. I will urge my friend Kushal to further to speak for.
Types of systematic errors. Offset errors and scale factor errors are two quantifiable types of systematic error. An offset error occurs when a scale isn't calibrated to a correct 0 point. It's also called an additive error or a zero setting error. A scale factor error is when measurements consistently differ from true value proportionally, for example by 10%. It's also referred to as an correlational systematic error or a multiplier error. Next slide. Sources of systematic errors. The source of systematic error can range from your research materials to your data collection procedures and to your analysis techniques. This isn't an exclusive list of systematic error sources because they can come from all aspects of research. Response biases occurs when your research materials, for example questionnaires, prompt participants to answer or act in inauthentic ways through leading questions. For example, social desirability bias can lead participants try to conform to social norms even if that's not how they truly feel. Experimenter drift occurs when observers become fatigued, bored, or less motivated after long periods of data collection or coding and they slowly depart from using standardized procedures in identifiable ways. Sampling bias occurs when some members of populations are more likely to be included in your study than others. It reduces the generalizability of findings because your sample isn't representative of the whole population. Reducing systematic error. You can reduce systematic errors by implementing these methods in a study triangulation. Triangulation means using uh, multiple techniques to record observations so that you are not relying on only one instrument or method. Regular calibration. Calibrating an instrument means comparing what the instrument records with the true value of non-standard quality. Randomization. Random sampling methods that help ensure that your sample doesn't systematically differ from the population. Masking. Wherever possible, you should hide the condition assignment from participants and researchers through masking. or blinding. Thank you. This was our epidemiology. Our topic was epidemiological approach, descriptive and analytical approach, potential errors in epidemiological data. Thank you, everyone.